quick review on number 2. We wrote our polynomials in factored form. That's always the first step, if possible. Then I like to find my wholes first, and so wholes come from common zeros from the numerator and denominator. So x equals a -4 was the missing whole. And we got to see that on our decimals, what a whole looked like. Then the vertical asymptotes came from what was left in the denominator. That turned into a 0. So I set x minus 2 equals a 0, and I found the vertical asymptote. Remember, a whole is a whole. It doesn't have no other names. The x-intercept is what made the numerator 0, because that's the definition of an x-intercept. Where does the graph cross the x-axis where y is 0? So that's where we get our ordered pair. A whole is a value, asymptote's a line, vertical line, and then an intercept's an ordered pair. And the y-intercept, the fun one, I like to find this one. I look at the constants and reduce. So this is my scratch paper. Here's my final answer for y-intercept. You can find all these things on decimals.com. Put in either the factored form or the original polynomial, and you've got the answers. And you jump down to number 3, refactored. And again, if you're watching this because you're gone, please just pause the video so you can write down the notes. The factors of a difference of squares. I took the square root of 1, square root of x squared, and then changed the signs on each factor. Oh man, I messed up, didn't I? X minus 4 doesn't factor. Well, pickledy-dee, let's do a redemption on number 3. Yay. Now you can, all you had to do, let's go ahead. What I can do, I'll just put a squared. Let's say this example had a squared there. So we didn't do anything wrong, we just put a squared in there. Okay? How about that? That'd be easier fix. Make this an x squared minus 4. That's what I read. It wasn't there. I apologize. Vehicles. Nothing else. The only thing that changed was the vertical asymptotes would have been 4, x equals 4, so that's okay. We'll just change the problem. There we go. Okay, no harm, no foul. That's easier than starting all over. Okay, I looked to my made-up denominators and got the vertical asymptotes. There were no wholes because there was no common binomial that I can get a 0 from in numerator and denominator. And x-intercepts came from numerator, y-intercept came from reducing that fraction. So let's do that one more time and then we'll get into the homework. Number 4 is what it is. So this one cannot be factored. So it's x plus 2 in the numerator, x squared plus 2 in the denominator. We're in the real world again, so there's no complex solutions that can be graphed on a real xy axis, so we just take what we got and answer the questions. So there's no wholes. These two are not alike. There's that. Vertical asymptotes come from what makes this denominator 0. And if I set x squared plus 2 equal to 0, x squared equals -2 does not exist in the real number line. So x is positive and negative square root of -2, which is positive and negative I square roots of 2. Therefore, in the real number story, there is none. So if I put this on the Desmos, which I can do, you can see that there's no vertical asymptotes in this story. But it still crosses the x-axis. That's what the x-intercept is. Because I can set x equal plus 2 equal to 0, and I get negative 2, 0. And the y-intercept then comes from reducing 2 over 2, which is 1. Okay, so you can look at that at Desmos at your leisure and see that relationship. So that's, you see why the vertical asymptotes in the real numerical system don't exist. So that, but it's still a very complicated rational function for sure. What I did. We're ready to go to our notes for the homework. So if you want to open your homework, that's fine, but please take notes as well. Oh yeah, I got it right in period 4, so that was good. Okay. So the name of the game are graphs of complicated rational functions. Don't want to ever forget what our purpose is. Our little homework notes gave us parts of the characteristics. Now our homework's going to give us more characteristics. There's lots of characteristics about a function you can find. So here, right off the bat, number 1, they ask us to find the domain of the function. And we did this with simple rational functions. So it should be a familiar game to play when you're looking for the domain. They're starting us with, and you're going, well, that's a pretty simple rational function. Well, the reason why it's undercomplicated is because there's a variable in the numerator and denominator, where simple functions just had a variable in the denominator. So you read the directions, and it says drag and drop the numbers or symbols into the boxes to show the domain of the function using inequality, set notation, and interval notation, and determine the x value where the graph has a hole or vertical asymptote. Then it notes, use a graphing calculator to check your answer. So the only thing on the test I can ask you for, what is the domain? Okay, but you don't have to use the graphing calculator to check. The domain is all but what makes the denominator 0. Do you remember that? I did the set notation first. This is set notation. I just pulled it out and had the not equal to sign. And then they're going to have you put in the inequality notation. X is less than negative 8, or x is greater than negative 8. So these are the box. When I put boxes around something, that's what you'll be filling in. But they're not all just -8s this time, because they're going to have you put in the inequality signs. I'm sorry, infinity signs. So on the first infinity sign, you put -infinity. Then you put in your -8. Then it jumps over past a -8. Remember, soft brackets mean you do not include a -8. Then you put the positive infinity. So a little extra work there that you didn't have to do in simple. So the domain has to do what the x can't be. You tell that story several different ways. This is set notation because there's sets around this guy, like this. This is inequality notation because it's just the story. And then this is interval notation because it's got the soft brackets. So I did it out of order. I think the set notation they have in the middle, but I like to do that one first. It's the clearest one to me. The rest are a little muddy. Then they ask us for the asymptote, the vertical asymptote. Because there are horizontal asymptotes in complicated rational functions, but right now they're just asking us for the vertical asymptote. And that's where it's a line, so it's the never never line. So they just put in that -8 because that's what it's never going to be. So you're not going to use all your choices on your drag and drop. So don't let the distractors fool you. Got your number line in order. -infinity on left, positive infinity on right. It's a lot of notation, right? It's just writing down what you want to say. It's math grammar right there. Okay, ready for number 2? This is a great example of a little more complicated function. My function here has got a quadratic, x squared plus 2x minus 3 over x squared minus 4x plus 3. And we got to come up with the domain. First things first, we didn't have to factor in number 1, so we're going to factor the polynomials. Factors of 3 when subtracted give me 2. Well, factors of 3 are just 3 and 1, so that's easy. Yeah. Easy for me to say, right? When you multiply them, you get a -3, but when you add them, you get a +2. Factors of 3 when added give you 4. There's only 2 factors, and they both have to be negative. So I'm going to do the set notation first for the domain. This is easy for me, easiest for me. Set of all x such that x cannot equal 3, and, so you're going to put in the 3, and x cannot equal 1. Wait a minute, I thought you, what? I'm talking domain. So domain's made up of wholes and asymptotes. Domains have no-nos of wholes and or asymptotes. So a whole is what the domain cannot be as well. Whatever makes denominator 0. That's the no-no. Now, order didn't matter here. Order doesn't matter here, but order does matter when I go to put the inequalities. I start with a smaller number because x is going to be less than the smaller number on the number line, or x is going to be between the two numbers on the number line, or x is going to be greater than the larger of the two numbers. So order matters for inequality as well as interval. So interval, negative infinity, and then you go to the 1, because he's smaller. Then you go from the 1 to the 3. 3's larger. Then you go from the 3. Am I falling off the chart here? To positive infinity. Okay, this one isn't a drag and drop. I think this one is a drop down menu for the infinities. Oh no, I can't find it. Number 2 is still drag and drop. So you can use a 1 and 3. Ran right off the edge of the paper. So, like we said, here's the whole. So the whole is where x is 1. They're going to have you put that in there. Put your 1 in there. That's what makes x minus 1, 0, right? And then the vertical asymptote, I'm getting lazy, vertical asymptote is a line. Oh, I don't want to put equal, I want to put a semi, I want to put a colon because I don't want you to get confused with the equals. X equals 3. That was the one that was alone. Vertical asymptotes are blue. Up here to down here. Still in the screen there? Yeah. So that's where I got my 3 from. Okay, friends? Vertical asymptotes. That's where our homework notes help us. Be able to know where we got the whole and the vertical asymptote. So be a good factor person. Be able to factor your polynomials correctly, and then the rest is gravy. Thankfully, they do it like when they have drag and drops, it's like having a word bank to choose from. You know, so you know you're going to end up with these stories here. So you would, you got a range to pick from. So if you didn't get one of those numbers, then you know you did something wrong. They threw this one in there to make you crazy, and yeah, 0's always a good liar right there. So, yep, there's that. Okay, that's just what it looks like on your screen when you get in there. And you can look, you would see a whole, if you went to where x is 1 and you took your cursor on the curve, you see where that's undefined. Okay, number 3, they're going to ask us to do something completely different. We get to practice our division skills. You're good at dividing polynomials. They say divide the numerator by the denominator to write the function in the form where the quotient comes first, and determine the function's end behavior. that means what's the range. Enter the range using an inequality, set notation, and interval notation. So we're finding the range for number 3. So number 3 is about the range. And in order to find the range, you've got to take 3x plus 1 and divide it by x minus 2. Rewrite it as a division problem. You're going to use long division. Alrighty. So we have x minus 2 as a divisor. 3x minus 1 under the division bar there. How many x's go into 3x? 3 times 3x gives me 3x. 3 times a negative 2 gives me a negative 6. Did I copy that right? No, I didn't. That's a plus there. Plus, plus. So catch my mistake there. It's a plus here, so put a plus there. Okay. Draw the line. Change the signs. Add down. These two go away. I get a remainder of 7. So I can rewrite this function as quotient. And that's what you'll get to put in your software, what you got for your answer, plus your remainder in the numerator. And they went ahead and had your divisor down below. You'll be filling in quotient plus remainder. It's like writing a mixed number with polynomials. Yay! So you got to do the division to know this number. But a range comes from what it can't be. And that's that number 3. So the domain, x can't be 2, but this one's the range, the y's. So we've got 3 forms here. For the range, y cannot equal 3, because that's always going to be a number added to 3. So y is less than 3, or y is greater than 3. So 3 is your missing value. And then finally, in notation, you put in the parenthesis, negative infinity, that's the drop down, comma 3. So you drop down and pick a negative infinity, put in a 3, and it is after the 3 to positive infinity. I put myself in these little boxes. Shame on me. There we go. Hopefully you can read that. So negative infinity comes first, positive infinity comes second. Really good indicator if you guys understand how notation goes. We've been doing this for, every once in a while, I'll ask you about domain and range, domain and range, domain and range. Range is the Y, guys. Domain are the X people. So this was the range. Kind of fun. So now you can tell me if there's a hole, what the vertical asymptotes are, what the x-intercepts are, what the y-intercepts are, what the domains are, and what the ranges are. Look at all that. All those choices. You guys know everything that you need to know. Just got to remember how to factor and remember how to divide. Yay. Okay, we'll do one more for the good of the cause. It says divide the numerator by the denominator and write the function in the form where quotient comes first. So my original function, and then they want to know the range. Original function is x over, oh, they even have it factored for me. That's nice. X minus 4 times x plus 5. And so I want to know what my answer is. I think this is supposed to be an arrow. It points to the answer. They have a blank equals. Then they have the original function they gave us. Plus 5. Here's the secret. If I multiplied this out, that's x squared. And that means x squared would be my divisor. And if I ask myself, blah, 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 how many x squareds are in x? Could you answer that question? Can I multiply x squared by anything to get x? Can I make a higher power, a smaller power in polynomial land? No. So 0 is the quotient. And the remainder is the original polynomial. So when there is 0 as the quotient, the range, the y, guys, we've got a drop-down menu, interval notation. The y will not equal 0. Right? Oh, yes, it could. It could equal 0. Because if I put in a number in here, what if I put x equals 0? Because I'm saying this will always be a number. Is that true? If I put a 0 in here, I get 0 divided by negative 20. Is that allowed? Can I take 0 divided by negative 20? Can I do that? Is that okay? So if I have 0 plus 0, then y can equal 0. So if y can equal 0, y can equal anything. Okay? So therefore, how do we write y equals anything? Okay? It can be from negative infinity to positive infinity. That's what it goes for the inequality. That's what it goes for the set notation. And the interval notation is negative infinity to positive infinity. So that, because the numerator's power is smaller than the denominator's power, the range has no exceptions. So let's look at that. I'm going to look at that at Desmos. See what that kind of polynomial looks like. Unfortunately, my video people will not be able to see this, but I will. I don't know if I can escape it. Can I escape it here? I'll go ahead and close the video out and then invite whoever's watching this, if you're gone, to go to Desmos and graph this function so you can see what it looks like.